for these strange sounding theories in quantum mechanics. What I intend to do is present what we actually know, but from a geometry point of view, which is extremely rarely covered. Geometry is a forgotten science at this level, unfortunately, because geometry is for visualization. I'll be having more lectures in this series. This is the beginning of a new series I'm calling the Equinox series. We just completed the Solstice series, which was devoted to the other direction, which is going out to get to the infinity, physical infinity. I've covered that, and I urge you, if you are at all interested in understanding the universe fully, visualizably, understandably, to cut through the red tape and BS of things like the Big Bang and cosmological expansion, insane sounding. They each have their reason, and there is a reason for the Big Bang. It has, by the way, been disproved. However, it's not going to go away because of the nature of how science works now at this level. I've covered that in previous lectures. So, we shall need two related metric spaces to describe four relationships. Metric spaces are abstract. They're abstractions. But we will obtain a geometry in this abstract space. This is a geometry I've already covered in previous lectures, but science is nothing if not the ability to summarize. That's what I'll be doing here. This covers a lot of information that I have gone into in great detail in the past, but here is the time for synthesis. This is for the purpose of understanding, for a layman, someone with just an ordinary mind, an ordinary interest, not trained in calculus, not devoted to highly specific and specialized techniques, theories, models, or partisan activity of any kind. This is for everybody. That's not easy to do, as you can tell. If you do keep up with any presenters on YouTube, or you are an avid book reader, lecture follower at a university level, or you just like to keep abreast of the times, there's a lot of hype. A lot of hype because it's exciting. The universe was only really discovered out to the galactic level coming up on 1 century ago. In exactly 1 month, on October 6th, I'll be celebrating the 100-year anniversary of Edwin Powell Hubble's discovery of a Cepheid variable in Andromeda, which unlocked the rest of the universe to physics. To continue now reading. Having then the geometry, we can describe force balance. The two metric spaces are space-time and time-space. Light reveals the time-space continuum, and gravity reveals the space-time continuum. You can see that this is a postulate. If you don't have familiarity with the terms axiom, postulate, and theory, an axiom is a basis statement, a postulate is based on axioms, and a theory, if one is required, if one does not know or one is not sure what the theorems are actually indicating in the way of what can be understood and explained to a layman, the purpose of science is that. Unless you're in technology, that's quite different. Light measures time-space, the spatial effect of light-time. Now, you've heard of a light year. That's a unit of measurement in light-time. So that's all light-time means, is something related to light speed. A light year is considered to be a distance, but it's also a time duration. Gravity measures space-time. Albert Einstein is the one who uncovered that, according to his theory, which he backs up with some pretty convincing mathematics, although there are some loopholes. That's the level that we're at in cosmic science, at both ends of the spectrum. Gravity is a cosmic scale phenomenon. Now, we can measure it fairly directly within the solar system. After that, we have to extrapolate. But that's exactly what cosmologists have done and continue to do to measure what they think is either the expansion or contraction rate or the topology of the universe. Vastly interested in all aspects of this. Gravity measures space-time, the temporal effect of space. Temporal refers to time. The effect of space on time. Now that's rather novel, and I'll be expanding on that, but just accept these statements for now without believing or disbelieving them. If you want to get far in understanding science, never believe anybody. Science is not based on belief of any man's statement. It's not belief in a theory. It's not belief in a model. All right. Atoms are a space-time contraction point. Atoms are space-time contraction points due to protons. That's a highfalutin, somewhat abstractified way of saying that gravity pulls everything down to its center. That center, by the way, is a point. But it's abstract. It's not a physical point. It can be construed as a geometric point. That's valid. But as for it being a physical point, no, that would be a proton. The proton is the only real, I won't say real, that's the wrong adjective. I'll put it this way. If there is such a thing as a physical point, it's manifested in the proton because of the effect that the proton has on the space around it. Now, if there are three kinds of space in mathematical language, and this is something that's going to help you if you believe what I say. Space can be considered a pure abstraction. That's really the axiomatic basis of what we call space. We can postulate a geometric space in abstract space. And from the geometric space, what we're looking for is a match on physical space. Physical space is real, but it's been somewhat difficult to define. So has time. So let's go on. Electrons are time-space contrapoints. This is a discovery that I made, and you must not believe me unless you see clearly what I'm saying. I have to prove that to you in a way that you can justify in your own mind that that is a valid statement. That's called a postulate at this phase. Or it can be called a theorem. All right. This is why the two associate spherically. That's my business. Even in my phase as a database analyst, after I had retired, I continued to use my database skills in order to study galaxies, which you know have a spherical component and a linear component. That's enough there. I don't want to get sidetracked. But that's why I say the two associate spherically. That actually is a proven fact. Electrons, as you know, orbit around the nucleus, which is composed of protons, and another particle, which I've disambiguated somewhat in previous lectures. The difference between a proton and a neutron is not very much of a difference in terms of their weight and in terms of their radius, insofar as that can be computed. Protons and neutrons are so closely related that they actually spontaneously change from one end to the other under the right circumstances. A great deal of research has gone into that phenomenon for fairly obvious reasons. And now to complete this page, we think of electromagnetism as a charge relationship plus and minus. What we do not yet think of is the extended relationship. I'm going out on a limb here, but I have proved this to myself. So, with suspended judgment, just hear the rest. Positive charge is gravity. Now that has not been proved, and if it could be proved, it would be the grand unification theory in the older sense of the term. The term has actually changed meaning, but it's not greatly important. It's a somewhat grandiose statement for stating that we're looking for the relationship between the charge relationship in the atom, which is electromagnetism, and gravity. And so far, nobody has found a direct connection, but it's obvious that they're related. All of this is extremely important in understanding cosmic science. Positive charge is gravity. That's a theorem. Negative charge is counterspin. Okay, I'll be talking about that to explain what I mean by that. It has to do with angular momentum. We think of magnetism as being charge-induced. Magnetism is gravity in a different scale frame. Well, it can't be thought of as a gravitational object, but there sure is a strong similarity, isn't there? The electrons form shells around the protonic core. In a planetary system, there is a linear component where instead of the planets going all around spherically, as we conceive the atom to be, the Bohr atom as it's called, they do go around the star, but on a disk. All right. Magnetism is gravity in a different scale frame is a hypothetical way of equating the two on a direct relationship. That would have to be substantiated, at least in geometry, but really what science looks for, particularly these days, are measurables, meaning measurements. We'll be getting into that too. This is a quite deep subject, but I'm trying to simplify it down to its most understandable form, which means that there's a lot left out, called the proofs, yes. So this is an introduction to the proof sequences on which science is based, okay? Now you know all that. Electricity is its counterpart, that is, the counterpart of magnetism. And light is now known to be directly related to electricity. Maxwell discovered that, and nobody has doubted it since. So that's an interesting relationship. That magnetism can be thought of as small-scale gravity, and if so, you could extrapolate what is electricity related to. It's related to light. All right. The induction of electricity always induces magnetic effect. They never occur by themselves. In one use of the word duality, that is called a duality. What I'll be attempting to prove is that light propagation and gravity are also related at a different scale. That has not been proved, barely even surmised. The induction of electricity always induces magnetic effect. The contra is also true. Wherever one finds a magnetic effect, there is electricity somewhere. A lodestone manifests magnetism, but it's hard to see how it manifests electricity. However, it is there. This is predicted by Emmy Noether's force symmetry. I'll be going into that in some detail. That is the basis of my insight. The induction of light. What I mean by induction here is not the electrical, or I should say perhaps the electrical engineering term. Induction has a specific meaning in electrodynamics. However, induction also has a more general meaning. Really the origination. How is it produced? What causes it? So the cause of light similarly requires contraspin conservation. Now I've already introduced the terms spin and contraspin. I believe that I've proved this. The induction of light, this means when light leaves its source. What is the source of light? Is there more than one source of light? From a macroscale, a human scale, there are many sources of light. Fire, electrical sparks, stars, all produce light. The induction of light similarly requires contraspin conservation. Just think of that for now as the conservation of energy. Because light does produce a force, or you could say it manifests a force, and I covered that in a little video on light sails. You can spread a sail in a craft, say you construct it somewhere near the moon, and unfurl the light sail. Your craft will start to move away from the sun under the force of light. So light does manifest a force. The difference between electromagnetism and light is that electromagnetism remains bound to the gravitational force of a protonic system. That would be an atom. The source of light is atoms. Light always comes from an electronic shell. It does not come from the protons. It comes from the electrons. And so electrons and light are in some way the same thing. And I'm attempting to give an idea of how you can differentiate between the two. What's the difference between light and electromagnetism? Well, electrons are electromagnetism bound to an atom, whereas light obviously is no longer bound to the atom. That's the difference. That is the origin of the propagation of light, what I call the induction of light. It's that simple. I do try to use precise terms, but very often precise terms are a little too precise for an audience or person who's not familiar with the terms. Therefore, they should always be explained. And I just want to throw this in. Whenever you see one of those calculus equations, or any equation, such as the Dirac equation, or the Einstein field equation, the famous EFE, these equations are almost never given with their English translation. I consider that to be a major sin in modern science. It should be required by scientific law that any time you write out a symbolic equation, which is redundant, that's what an equation is, it's a series of symbols, there must be a paragraph that it translates it. This is virtually never done. I try to do it every time because it's one of the greatest ways that a reader, someone curious, can understand what the you-know-what equation is actually saying. This is a particular sin in calculus, but that's enough ranting. It's very easy these days to get into ranting. The difference between electromagnetism and light, therefore, is that electromagnetism you can think of as an electron. That's what causes it. But the magnetism does not come from the electron. The electro component comes from the electron. The magnetic component, which is a centripetal force that pulls in just like gravity. That's why they're so tantalizingly obviously related somehow. They're the only two known centripetal forces. There's a footnote. It's very important in science, although you must pause very often in a presentation to explain things. It's very important to maintain continuity. The difference between electromagnetism and light is that electromagnetism remains bound. Okay. When enough centrifugal force is acquired in the atomic system, this would be by the addition of energy, some component. If you add to a system, you have to account for it because of the conservation of energy. That's all centrifugal force means here, is that something is being added to the system, and I have identified that as centrifugal force in this context. But I haven't said what it is yet. I know it's centrifugal. That's what we're going to try to prove. When enough centrifugal force is acquired in the atomic system that holds the protons, then the electronic spin balancing protonic spin, protons are said to spin, although that's not really their function. The function of an electron is to spin because an electron basically is motion, whereas a proton is basically spatial. We're going to get into that much more deeply, but I'm going ahead to give you an idea where this is going. When enough centrifugal force is acquired, I'll say just force. When enough added force is acquired in the atomic system that holds the protons, then the electronic spin balancing protonic spin must release some of the E component of EM. That would be the electronic or electrical component. This yields light propagation, a manifestation of centrifugal force, and that's the statement of my theorem. To go on here, conversely, when enough centripetal force is applied to an atomic system, the elasticity of the nucleonic core might be penetrated. This is the source of an atomic explosion. So to give two examples to illustrate the two statements that I've rather precipitously made, when an atom is struck by a photon such that the photon is absorbed, then the system is imbalanced with respect to what it was before the photon became part of the system. In light propagation from a star, that induces a most interesting phenomenon, that the atoms in the atmosphere of the star receive the photons that are streaming out, and as these photons hit the atoms absorb the photons and emit another photon that has a different signature that can be read on Earth. The science of the study of that phenomenon is called spectroscopy, and that's how we got redshift, which led to the Big Bang Theory, and a new rung on the cosmic distance ladder. So you see the strong relationship between quantum dynamics and cosmology. Indeed, astronomy itself. Conversely, when enough centripetal force, squeezing the atom with pressure to see what happens. Yeah. By the way, I'm sorry, but I got to throw this in. Albert Einstein, at first, after his E equals mc squared, did not believe that an atomic bomb could be invented. Well, it certainly was, so don't blame Albert. He wasn't trying to invent an atomic bomb as far as we know. Conversely, when enough centripetal force is applied to an atomic system, the elasticity, that's a Boscovichian term, but it's also well known in high energy physics, the elasticity of the nucleonic core, that means that it doesn't break easily. You can apply pressure to it, but it won't budge. It has to be an enormous amount of pressure. But if you can pressurize the nucleonic core enough, it will explode and release energy according to the formula E equals mc squared. From that, we get a fission explosion, or a fission reaction, a fission phenomenon, where the protonic core breaks and releases energy. That's really the source of atomic energy. It's not, however, thermonuclear energy, which is a strange name. Fusion energy is actually the opposite, but we'll cover that later. You may be aware of that. If you are, this may be quite tantalizing to you. I hope it is. All right, the elasticity of the nucleonic core might be penetrated, breaking the curved bound of binding force. This has to do with the strong force, but not yet. The binding force at the centripetal core, that's the nucleus, is in inverse proportion to the centrifugal force, giving light its velocity component in time-space. We're going to be explaining time-space in this context. Time-space and space-time, I have proved to myself, are two different things. Thus, light traverses the same space as gravity. Remember, our definition of space has three definitions. I'll let you figure out which one is meant here. It's not always clear what these things mean, even to the people who say them, okay? Thus, light traverses the same space as gravity. That's kind of obvious. But with inverse spheric valence. In other words, gravity pulls in. It's called a centripetal force. It's pulling into the core. Both for the atom, where it's called magnetism then, but that's also a centripetal force. I'm really trying to make this simple, but of course, if it were simple, it would have all been figured out by now. So they do traverse the same space. Gravity is a force. It's sometimes called a pseudo-force because it's not quite the same as other forces. It's more passive. And the way Albert Einstein phrased this is through an expression called time-space curvature. I want you to doubt that. Time-space curvature has a loophole in it because you're curving both space and time. When you say that, you're saying they both curve. That is, time-space is a thing, or space-time in the case of Albert's terminology. Space-time itself curves. What I'm saying is that space appears to be curved under the influence of a gravitational source, like the Earth creates a gravitational field. That's all that's being said. So gravity is a force in reciprocal balance with another force inducing light speed. Okay, so I'm saying that gravity is reciprocal to light force, but I've expressed it as light speed because the photon is an exceedingly interesting thing. You may have heard of the wave-particle duality. That applies most acutely to the photon, where the difference between a wave and a particle was first noticed was in the phenomenon of light. There are some excellent videos out on YouTube that explain that to extraordinary detail, but I trust you understand that. It's not truly difficult to understand. What you're understanding, though, is a paradox. Because how can something be both a wave and a particle? That's actually the problem that I believe I've solved, which, if I'm right, in any way, might be helpful. I take that for granted. I hope you do too. Now, whether I'm right or not, hold off judgment. Either way, don't believe or disbelieve what I'm saying. As a scientist, you're looking for the proof so that you don't have to worry about believing anything, because you're confident that you can also prove it, so that anyone can prove it. That's what science is. It's something that we all can know because we all can do the same proof. That's science, okay. The induction of electricity with respect to magnetism, I also use a lot of abbreviations. With respect to, I've just learned to always abbreviate that WRT, so I hope my notation, my code, it's a mathematical convention to do that, which I've extended to just words, but that's all it is just an abbreviation. The induction of electricity with respect to magnetism is thus a bound scale version of the same effect in unbound scale version. Gravity propagates infinitely on an asymptotic attenuation, which is quite a spooky thing to say. In other words, gravity itself is a non-local phenomenon. That's why there's a great deal of interest now in gravity waves, which are, you could say, is still a somewhat controversial topic, although a great deal of hullabaloo has been issued recently over the past years, and I'll just say this millennium. Gravity waves are a huge topic. I don't want to get off on that though, but in context, what I'm saying is that at the atomic scale, the electromagnetic relationship is similar to another relationship in unbound space, that is non-atomic space, just what might be called free space, more abstract space, large-scale space, just space. Gravity propagates through that, whereas magnetism is a very local phenomenon comparatively. We're getting to the point, though. I'm pretty sure you can sense it coming. So there are two scales to this relationship. One is the electromagnetic relationship, and the other one is the gravity light propagation relationship. All right, let's see what we can do with that. That's an interesting hypothesis, I should have to say. I believe I've proved this. All right. The induction of electricity with respect to magnetism is one thing. But the unbound scale version at cosmic scale, which is gravity and light propagation, I am saying are the same thing. That would be a formulation of the grand unification theory. We're going to need the geometry and the mathematics to support that, but intuitively, I believe that that is self-evident. It would be hard to state it more clearly, I think. Is a centripetal force and a centrifugal force that are being manifested in free space, that are also manifested at the atomic scale. All right. Rudger Josip Boscovich, who is a scientist who lived about 250 years ago, virtually discovered this relation. What he actually did was at least to show the relation at domain transition scale. That's a new term. That's a term that I invented. I'll be talking about that extensively over the next few lectures. I already have in previous lectures, but in specific, in-depth extrapolations on certain principles. This is the summarization of all that research that really was done by Rudger 250 years ago. His name is now coming back up in top-level physics because a lot of men have figured out that Rudger got it. Rudger got it. That is, he actually described the Bohr atom before the atom was even known about because of his force relation mechanics. Extraordinarily profound. And I am not the first man to notice that. So that's why I'm bringing up his name. He virtually discovered this relationship, this relation. That's what a database programmer looks for, is relationships. So do geometers. So do scientists when they're in a proper frame. They very rarely are these days. Geometry has slipped by the wayside in favor of mathematical, basically numeric relationships, which are then projected back onto the universe. That's a very dicey thing to try to do, which is why we have a lot of these harebrained theories. All right. What he actually did was at least to show the relation at domain transition scale. That's the atom. That's the domain transition scale. What do I mean by domain? Rudger identified two domains which are now perfectly accepted. One is the space domain, the other one is the time domain. These are two physical entities, which is a tremendous thing to be able to say if you can prove it. It's been proved. I'm going to show you. A lot of the quantum paradox has to do with domain transition. The other aspect of quantum mechanics that makes it quite mysterious is the fact that our number system is inherently limited with respect to cosmic space. Cosmic space is spherical, both at the atomic scale and at the cosmic scale. Everything is spherical. Virtually everything is spherical. In physics, virtually everything is spherically oriented, from the atom to stars to very likely the universe itself is spherical. But we use linear numbers, linear algebra. Everything, our numbers are a linear system. That's a one-component system, whereas spherical space cannot be fully computed with linear numbers, because if you look at a sphere and take its diameter, the relationship between the linear component there, which is the diameter, and the spherical component, it's quite obvious that the line cannot even know about the sphere. That is called the quantum limit of measurement. You may be aware of the measurement problem in quantum mechanics. All of this fits, and I'm hoping to show you that it all fits in a way that you can see, that you can perceive. All right. What he actually did was at least to show the relation at domain transition scale, at atomic scale, which we now call the atom. These are two forces, gravity and light. Light manifests a force. You could say it is a force. It certainly is. You can use the force of light the same way that you can use the force of wind. All right? And there are actually patented diagrams of light sails, and light sails are being engineered on Earth right now for use in outer space. You can check that statement. So to say that light is a force is not an outlandish statement at all. Force mechanics has not been the domain of top-level science since Rudger Josip Boscovich. There is such a thing as force mechanics, but it's not really a bona fide field of study. I'm going to show you that it likely should be. All right, so to go on and finish this page, these are two forces, gravity and light. Gravity spins. Now, when I say spin, the reason you might think that gravity does not spin anything, and I would have to say, superficially, it's not obvious that gravity spins anything. I'm going to show you that that's actually what it is. It's a spin component. But that's part of my hypothesis, so take that with a grain of salt for now. But what I should probably say is gravity pulls space. It pulls it. When you say pulls, it's not spinning, it's just going linearly from all directions. That's not truly a spin. Actually, though, it is, and I'll show you why. Reciprocally, light is time spinning out. That is a major hypothesis. Don't believe that for now. Wait until I prove it. But that is the correct way to say it. So gravity pulls space in. I'll just say that light goes out. Light propagates spherically. Now, Newton did not think so. And again, there's our YouTube videos describing what I'm saying very briefly. But Newton conceived of light as what he called corpuscles or corpuscles. In other words, particles, which Einstein proved later that Newton certainly had a point. They're called photons. However, when traveling through space, Christian Huygens showed that it manifests a wave form. And that also is known, and that is the quantum paradox restated. There are many ways to state the quantum paradox. But the first way that it was perceived, and I think the way most laymen, such as myself, and probably you as well, perceive the quantum paradoxes as the wave-particle duality, referring to the photon, but it does affect other particles. So, it's a broad statement that applies to the photon in particular. It's not limited to it. Reciprocally, light is something going out. It may not be time spinning. I know that it is, but you don't know that. But that is what I'm attempting to prove. So I'm just stating my hypothesis in the language that I understand it in. That's rather normal, but it's a little bit frustrating, I think, to someone who's trying to follow what in the world you're saying. Just accept that for now. That light goes out as gravity goes in. Light goes out from atoms, from the electronic shell. Light departs from electrons. Electrons produce light. But protons produce gravity. That's all that was just said. We call the space point a proton. Point is a very, very tricky term. But in its abstract form, it's most useful, and just accept it that way for now. I'm pretty sure you don't doubt that. that the proton, in some sense, is a point. It's a very special kind of point. It manifests centripetal force, whereas the electron manifests centripetal force. Okay? We call the space point a proton, and its structural form an atom. Okay? That the atom, therefore, is the manifestation of the protonic space. It's very limited space, but it is a small space. And so it looks like a small solar system that has a purely spherical characteristic. It's not linearized into a disk as is a solar system or a spiral galaxy. I hope that all makes sense. We call the space point a proton, and the now I say time point, that's part of my theory, but an electron actually doesn't have any truly spatial characteristics. It's a fermion. And a fermion is very hard to describe in the same terms that are used to describe a proton. Very strongly related to a photon. That is, electrons and photons are clearly related. Electrons produce photons. What do protons produce? Nothing like a photon. Instead, what a proton does, it seems to bend space in, which is a force. All right. We call the time point, I call the time point an electron. What it is a propagation point. The propagation of a spatial effect is from the proton. The propagation we call it energy, but energy is basically pure motion. It's not spatial at all. That's part of my theory. Okay. We conceptualize space, and I do capitalize that word when it's being used of physical space. That should be capitalized in my opinion. You don't need to adopt that convention, but I think it's a good one. Anything that helps clarify what is being communicated, such as a mere capitalization. The Germans capitalize virtually all nouns, not just proper nouns. And that has a certain advantage in scansion. But, again, I love to tell stories, don't I? We conceptualize space. Space is permeable to space-time. That's what Einstein said, is that space is affected such that it manifests space-time. So it's no longer just space, it's space with structure. It bends in, but space does not bend out. As space bends, it always bends in towards a gravitational center. Space itself has never been conceived to bend out, but it definitely, according to Einstein, bends in. That explains a lot. That's a good conceptual framework for gravity, is that it appears to bend space in. It's a good way to say it. Einstein did say it, and he proved that he had a good reason for saying it. So, space is permeable to space-time. Permeable, don't worry about that yet. That's part of what I'm trying to prove. That space-time, well, I actually already said it. Space is just space, no characteristics. But Einstein said, yes, space does have a characteristic. It bends. And when it bends, it always bends in, under a centripetal force, either gravity, or in the case of electromagnetism, under magnetism. If you take two magnets and put them at a distance, and they're close enough, you can feel the tug, and if you release one, it shoots and contacts the other one. That's spooky action at a distance. Absolutely mesmerized the ancients, and nothing has really changed to this day. Magnetism is an extraordinary phenomenon, but you can instantly see its relationship with gravity. That is already known, but very difficult to explain. I'm attempting to explain it. Using centripetal and centrifugal force balance. We're getting to the spin presently. As light transits the continuum, this would be the continuum of space. As light transits space, it reveals centrifugal force. It certainly does. It goes out spherically. That's under some impetal force. In other words, it's a velocity. Light has a velocity. It does have a velocity, as you well know, abbreviated c. Let's go on. As gravity transits the continuum, it reveals centripetal force. I hope that's obvious. These each are the combined force of their respective domain. Okay, so thus we have two universal domains, time and space. Rudger Josip Boscovich found the quantum transition algebra. Not even the men who have noticed the significance of Boscovich's force mechanics, not even they, I haven't heard any of them say what I just said, that he discovered the quantum transition algebra. My hypothesis, which I believe I have proved, is that it's the transition from the space to the time domain that explains quantum mechanics. The quantum may now be explained geometrically. To accomplish this algebraic synthesis, the relations can only be properly established in geometry. That is the geometry that I discovered in 2022. The algebra and the number system and algebra and geometry of spherical space that explains all this. Nobody knows this. So, that's my theory. And that's an hour. Let's finish this and sum it up. The quantum may now be explained geometrically. To accomplish this algebraic synthesis, the relations can only be properly established in geometry. That is, it's proved impossible to do with mathematics so far. What I'm saying is it can be done in the right geometry. The geometry being used in physics is, of course, linear geometry. I hope you realize that the Einstein field equation is the linear solution for gravity. I have found the spherical solution for gravity and much more. I've also proved that linear algebra is embedded in a higher system called spherical algebra, and that's the quantum transition algebra that Rudger Boscovich discovered. I was dumbfounded in August of last year, right in the middle, about my 250th lecture by then, trying to explain all of this, that I discovered that Rudger got it before me. That has been noticed. Anagalactic has discovered the algebraic geometry of spherical space. The effects of this discovery are significant to physics. And that may be the understatement of the year, the century, the millennium, and the history of science. So I'm quite excited. Whether I'm right or wrong, it's done wonders for me, but I want this to do wonders for science. So that's why I present these lectures. That's really, I had begun just by giving tours of the universe. That's all I wanted to do, was present the discoveries that have already been made, the actual facts, the actual discoveries, no theory, of what we've discovered in the past century. That was my original goal. My goal has changed because I was immersed in a discovery vector that's gone, for me, off the charts. All right, thank you for tuning in. This is Anagalactic, bringing you the secrets of the universe on this 7th day of September 2023. It's now a little after 7 p.m. here. We have a half moon waning. So we have another new moon coming up. I hope you're getting ready for some astronomy. The way to learn about the universe is done by you when you go out under the night sky and look up and think. Look, you have to do that. That's real science. The rest is just support information so we can talk about the wonders that we've seen and ultimately our sense of wonder, which is transportive and I believe transformative. Science is meant to make a better, happier person out of you. So do some astronomy, please. That's all I ever wanted to tell anybody. Look up. You won't regret it. There's no trade-off. There's nothing but good. How often do we do it? Do it more. That's my message. Thank you for tuning in. I hope I did not mislead, confuse, or confound you in any way. My purpose is to express the wonder of the universe to you so that you will be happy. This is Anagalactic from Chico, California. Thank you. Keep looking up, okay?